Hi students! Today we're going to do the study guide for the Intermediate Algebra final exam. And so this is the blank study guide that I have emailed to all of you guys. And so if you notice, the first part of it is typed because this is the study guide that the department puts out. But I didn't feel like it was really very helpful. So we're only going to do a few problems out of this. If you turn though to the back, you'll notice a lot of handwritten problems. And so these are a lot of the problems that we're going to focus on because they're more like your final exam. Okay, so what I have done is put together a list of the problems that you are going to need to do for the final. So these are the problems. There are 32. These are the problems we're going to do today for the final exam review. So this is it. These 32 are all that you need to study. So if you want to pause the video and circle these or highlight these are the problems that we're going to do. So let me talk about the test for a few minutes. So the final exam will be Monday and Tuesday, depending on which class you're in. So Monday, December 7th and Tuesday, December 8th, just depending on which day you have me. You're welcome to take it either day. You may want to keep in mind that if you have biology with Miss Suits, her biology lecture final is Tuesday. And so if you have her, you may want to be sure and come Monday for my final, just so that you don't have both finals on the same day. That's a lot for your brain to comprehend. So that's the deal. So pause and do these problems. Also, your final exam is going to be 30 problems. Okay, so it's really long, but that's okay because your 4th hour teacher is going to excuse you. Don't worry about the bus. We will drive you over to the high school. They know that you're going to be late the day of your final, so it's not an issue. But you will have 30 problems and they're going to be multiple choice. So I will provide you with a study guide. a Scantron. You don't have to worry about a Scantron. You will need a pencil and you will need a calculator. So be sure to bring a pencil, be sure to bring a calculator, but I will give you the Scantron. So you don't have to worry about that. Okay, well, let's jump right in and do these problems then that I laid out for you. So first problem for the typed set is number 7. Okay, so number 7 gives you an equation and wants you to solve for the letter H. Okay, so it's kind of strange because they don't put the whole numerator over 3. They put a 1/3 out in front and just multiply it. So it's a little different than what we're used to. This is the way that your final exam problem is going to look. But that's okay. I just wanted you to become a little more familiar with it. So that's why we're doing it to look like this. All right, well, before we start solving for H, we want to get rid of this denominator because we don't want a fraction. So my LCD would be 3. That's my only denominator. So if I multiply both sides by 3, I'm going to get 3V on the left. These 3's are going to cancel on the right, and I get pi r squared h on the right. Okay, so I've gotten rid of my fraction. Now I'm solving for h, that's what I want. So I'm going to divide by everyone who is not h. Okay, and I end up with 3v over pi r squared. And there's my H. So that would be my answer, okay? All right, that brings us down here to 23 and 24. Now, these are both the same type of problem, but I wanted to just do this problem twice because we really haven't had to deal with one of these yet. And so I just want to make sure you're comfortable with it. So you'll just have one of these on your final. So at first glance, you may think that you're going to be solving these systems of equations, but you're actually not. They don't want you to solve them. They want you to tell whether these two lines are parallel, perpendicular, or neither. Okay, well, let's first talk about that for a minute. So how do you tell if a line is parallel? Well, they have the same slopes, exactly the same slopes, same sign, same number, same slope. Okay, how do you tell if a line is perpendicular? Well, these have the opposite sign. So one's positive, one's negative, and the slopes are flipped, right? So it's the reciprocal. Some students don't like that word reciprocal, so I just say flipped slopes, but that's how you tell. And then neither, of course, means they don't have anything in common at all. Well, in order to tell this information about the slopes, you need to put both lines in slope-intercept form. So you're going to need to rearrange and put it into y equals mx plus b form. Okay, now I know there's not a lot of room on here, so that's when I'm going to bring in my little handy dandy paper here so that I can do this for you. So, okay, so 23 looked like this. And what I want to do is solve both for y. So in this case, I'm going to subtract my x to the other side. Okay? I'm just subtracting x to the other side. Now, I still need to divide every term by 4. So y equals negative 1/4 x plus, normally it would be 6/4, but I can reduce this to 3/2. Okay? Now I'm going to work on this guy. I'm going to subtract that 2x to the other side, and I have to divide everybody by, you know what I did? I'm doing 24 instead, aren't I? Ugh, no, I'm totally doing the wrong problem. See, this is why I need you guys here in person. Okay, this is 2x plus y equals 5. Sorry, guys. Okay, now we're cooking. Okay, so I still have to subtract 2x to the other side. But once I do that, I'm done. I don't have any y. So if I put the systems here right next to each other, okay, here's my two equations. All I did was solve each one for y. I just had to fix it because I wrote it wrong. Now what I'm going to do is compare their slopes. So I'm only comparing m. I don't care about their y-intercepts at all. I'm just comparing m. So these are definitely not the same. So these are not parallel. They're also not perpendicular because they have the same sign. These would have to have opposite signs. Also, these are not the reciprocals of each other. His perpendicular slope would be a positive 4/1. His perpendicular slope would be a positive 1/2. So these are, for number 23, neither, because they do not have the same slope and they do not have the opposite reciprocal slopes. Okay? All right, now let's try and do 24. Maybe I won't mess it up. Let's see. 24 is negative x plus 4y equals 6, and 2x minus 8y equals 9. All right, so again, we want to solve both of these equations for y. Okay, so in this case, I'm going to add x to the other side. Okay, now I'm going to divide every term by 4. So 1/4 x plus 3/2. Okay, that's my first equation solved for y. Okay, for this one, I'm going to subtract 2x to the other side. And now I have to divide every term by -8. This is going to turn this into y equals a positive 1/4 x minus 9/8. Okay, so now that I have solved these for y, I'm going to compare their slopes. They are exactly the same, so these guys are parallel. Now, in order for them to have a perpendicular slope, just so we can practice, the perpendicular slope would be negative because these are positive, and we would flip that 1/4 and get 4/1. So -4 would be the perpendicular. to this guy, just in case, just so you know. Okay, so that is how you handle the parallel, perpendicular, neither. Okay, let's turn our page over here then. We are going to be on number 40. Okay, now number 40, the directions here say solve. We are actually instead going to factor. So I'm going to get rid of these directions and I'm going to say factor instead. Okay, all right, because that's what it's going to say on your final. All right, so I'm looking here and I notice there is not a GCF. It is a monic, which is nice. I wonder if it could be a PST. Well, if we take the square root, we get x. Square root, we get 6. 6x times 2, this would have to be a 12x to be a PST, so it's not a PST. So it's just going to be a little monic. So we're going to take it like this. We're going to put our x's in the front. All right, if you like to do that A, B, C thing that we've been doing, A is 1, B is 13, and C is 36. So we're looking for two numbers that multiply together to give you A times C. That's 36. The same two numbers have to add together to give you B, which is 39. Okay, well 36 has a lot of factors. We have 1 and 36. We have 2 and 18. We have 3 and 12. We have 4 and 9. And we have 6 and 6. We have a lot, and then they start to repeat. So we want the pair of factors that also adds to give us 13. And there's only one of those. So that's what we're looking at. Now, on your test, this is actually not going to be a choice. It's going to say choose one factor. And so your choices might be x plus 6, or it might be x minus 9. It might be x plus 4, or it might be x plus 2. And so you're only going to have one factor. You know that these are the two factors. So find the answer choice that matches one of these factors. You won't have both. You'll just have one or the other. Okay, so that's how it's going to play out on the final. All right, number 51. Okay, number 51 says solve, and it is an equation. So we need an LCD that 4, 2, and 16 can all divide into. Well, that's going to be 16. Now, because we have an equal sign, we're going to multiply all the tops by 16. And we're going to get 80x over 4 minus 16 over 2 equals negative 48 over 16. Okay, so I just multiplied the tops. I left the bottoms. I'm just adding in an extra step here. Some of you don't need this step, but there it is in case you want it. All right, now in my calculator, if I simplify this, I get 20x minus 8 equals negative 3. Okay, now I'm going to add 8 to both sides, and I'm going to get 20x equals 5. Now be careful here, because a lot of times your brain will look at this and say, oh, that's great, x is 4. And 4 would be a choice, but it's not the right choice. Remember, you have to divide by the coefficient of x. So the answer is actually not 4. The answer is 1/4. And so you need to be really careful that you're taking your time with this test and do a really good job. All right, that brings us to 62. Okay, so here is 62 up here. Notice that it is radicals, okay, all the way across. Now I'm going to just lay down another piece of paper here so I can kind of work my problems up here. Now, in order to add or subtract radicals, you have to have the same radicand. You have to have the same stuff inside. So we can't combine these in any way. So what we're going to do is reduce. So the first thing I'm going to do is take 48 and I'm going to factor tree him all the way down. So I think of 6 and 8 when I think of 48. You can do it a couple of different ways if you want to. But when all is said and done, regardless of how you do it, you should end up with 4 2s and 1 3. Okay, and you want to check those. Multiply those together and they should equal 48. Now, we're looking for groups of 2 because this is a square root. So here's a group of 2 and here's a group of 2. So if I pull one of each of these out, that's going to give me 4. And then I have a 3 left over. Leftovers go under the radical. Please don't get those confused. Leftovers go under the radical. Now, I also have this 5 hanging around right here. So this 5 is going to have to multiply with this 4. So this is going to turn into 20 root of 3. Okay, don't forget that little 5 hanging around out there. All right, let's move on to the next one. So now I have a 45. Well, he's shorter because he's just 5 times 9. That's going to reduce to 1 5 and 2 3s. All right, I'm looking for groups of 2, so here's a group of 2. I'm going to pull out that 3, and I have a 5 left over. Remember, leftovers go into the radical. Okay, now, it turns out I have a 2 in front of this guy that I'm going to need to multiply by that 3. So 2 times 3 is 6, root of 5. All right, and then I have a minus for this one. So far, I still can't combine these because they still don't have the same radicand. All right, last one. So now I'm going to take 20, and I'm going to factor tree 20. Now, you can do 20 as 2 and 10 or 4 and 5, whichever way you like. When you're done, you're going to come up with 2 2s and 1 5. Here's a group of 2. And then you have a leftover of 5. And I happen to notice, again, there's a 3 out in front that I'm going to have to multiply by this 2. And I get 6 root of 5. Okay, now this is a bad example. I really don't even like it, but I think it's good practice for the radicals, which is why I wanted to do it. Because look what happens with these guys. They actually cancel. So you end up with 20 root of 3. Okay, so we're going to do another one that's handwritten later on in the back to help you a little more, but it's good practice just to make sure you remember who goes where. Leftovers go under the radical. Okay, all right, 72 is our next one. Okay, so we have this nice little parabola. This point, the vertex, they give us as 1 5. That's 1 5 is the vertex. All right, now we're going to also do another one. What if we had one that opened up at 1 5? What if this is also 1 5? We're going to do both of these problems just to make sure you're comfortable whether your parabola opens up or down. So there's 3 parts to this question. First question, is this the graph of a function? Well, remember, to find a function, you use the vertical line test. You move across your graph and you make sure that your pencil only touches one point of the graph at a time. So it turns out that yes, both of these are functions. Yes, both are functions. All parabolas are functions, whether they open up or down. Okay. What is the domain for this graph? Now, domain and range, they are going to want an interval notation. So remember, with interval notation, infinities get parentheses. All other numbers get hard brackets. So domain is going to be your negative x numbers all the way across to your positive x numbers. And remember, this parabola is actually getting bigger and bigger and bigger and bigger as it comes this way. It's not coming straight down, it's getting wider. So it's actually going to start at negative infinity and end at positive infinity. And both infinities get parentheses. Now for this one, same thing. It's opening wider and wider and wider. So it's going to start at negative infinity and stop at positive infinity. Those are always going to be the domains for a parabola, whether it opens up or down. Okay, that's actually the definition of a parabola, is that its domain is all real numbers. Okay, the range is different. So the range starts at the bottom with your smallest y numbers and goes to the top with your biggest y numbers. So notice these arrows are bringing it all the way down here. So we're starting down here at negative infinity and going up until we reach this point. This y point is 5. That's why they gave you that coordinate. And because it's a number, it gets a hard bracket. So starting here, going up to 5. Now what about the open parabola? Here, we're starting at 5 and we're going to infinity. And so that would be the range for the one opening, okay? That would be that guy. All right, well, we just have one more typed problem. We can find it over here in the back, okay? And we're looking at number 75. All right, so number 75 gives us a function. I know that because it says f of x. Here it is, nice little equation, and wants you to determine the value of f of 4. Okay, so what this is telling you is that x equals 4, and it wants you to plug it in and find the answer. So f of 4 is going to be 3 times 4 squared minus 7 times 4 plus 5. So all I did was plug 4 into my x's. Okay, I'm going to square this first. 7 times 4 is 28 plus 5. Okay, 3 times 16 is 48 minus 28 plus 5. And that is going to give you an answer of 25. And there you go. Okay, so make sure you're comfortable plugging those in. Okay, that brings us to Mrs. Holcomb's handwritten problems that I'm sticking in the back. Okay, here we go. So we're not going to do all the handwritten problems. Some of them we are skipping. So for example, we're not doing B, okay? And we're not doing number 4 on the next page, but we are going to do most of the handwritten problems. Okay, so first problem here, we have an inequality. Now this means write the solution using interval notation. So that's what it's going to want. Okay, so let's get our solution. So we are going to distribute the 4, and then we're going to distribute the 7. Okay, now if this were an equation, I would subtract the 4 because I like to keep my letter positive. But for inequalities, your letter goes on the left. So we need to leave our 4x alone, and we need to subtract 7x from both sides. I'm going to put this little paper down here. Okay, this gives me negative 3x plus 12 and a negative 28 on the right. Okay, I'm going to subtract 12 from both sides, and I get negative 3x on the left, and I get negative 40 on the right. Now, I have to divide by a negative 3 in this case. Remember, when you divide an inequality by a negative number, what happens to the inequality sign? It flips. And then really the best I can do with this little ugly answer is make him positive. So I will tell you on your final exam, yours will not flip. You would have like a positive 3. And when you divide it by a positive number, it stays, right? So don't flip it on your exam. But here, just as a little remember, if it is negative, you flip it. Now, we want interval notation. Some students find it easier to graph it first. You do not have to, but some students like it. Okay, so remember, if you have this bar under here, it's a hard bracket. If you're missing the bar, It's a parenthesis. So in this case, we have a hard bracket. So we have to decide, is the hard bracket open this way or this way? Okay, well, remember the trick is this point looks like this point. Those are the same. So your hard bracket is opening towards that point. And this is your interval notation. So you're starting at 40/3 with the hard bracket, and you're going to infinity with the parenthesis. And that would be your solution. Okay, so you want to just be aware of that, of how to find that answer. Okay. All right, moving on to number 2. Okay, simplify with positive exponents. Well, my first recommendation would be to clean up inside. Clean up inside. So I notice that I have 2 x's, okay, right over the top of each other. That means these exponents can subtract. So I'm going to do bigger minus smaller, 6 minus 2, that's a 4. And it's going to live in the bottom because that's where the bigger number was. Okay, there we go. Same thing with the y's. I'm going to subtract them because there's 1 over the other. So 3 minus 1 is 2, but it's going to live in the top because that's where the bigger number was. Okay, so I cleaned up inside. Now I'm going to distribute this -3 to those exponents. So y to the -6 over x to the -12. I'm just multiplying there. Okay, I cannot leave it like this because they're both negative. So in order to make this -6 positive, I need to bring it below the fraction bar. In order to make this -12 positive, I need to bring it to the top. And that's my answer. Okay. All right, that brings us to 3A. Okay, now for 3A, what I notice here is I have a slope and I have a point. Now, it wants us to write the equation in standard form. What is standard form? Standard form is AX plus BY equals C. That's standard form with no fractions on the left. No fractions with your letters. That's what standard form means. Okay, so because I have a slope and a point, the only equation I can start with is going to be point slope form. That's my equation that I'm going to start with. Okay, even though I don't want to end up that way, that's where I have to start. Okay, so here we go. I'm going to do y minus y1 equals m times x minus x1. Okay, now I'm going to clean it up. So I'm going to distribute a 0 through there. That's going to make everything over here 0. So y minus 6 equals 0. Now, standard form wants the letters on one side and the constant on the other. So I'm going to add 6 to the other side, and that's my equation. And that makes sense because a slope of 0 would mean a horizontal line, and this is the form for a horizontal line. Okay. All right, let's try it again where we have a normal slope. So this is m, and this is x1, and this is y1. So I'm going to do y minus 3 equals -2/3 times x minus 2. Okay. All right, I don't want to leave it in this form. I want standard form. So I'm going to distribute -2/3 through there. And I'm going to get y minus 3 equals -2/3 x plus 4/3. Okay. Now, I don't want fractions with my letters, and I've got a fraction with my letter. So my LCD is 3. I have an equal sign, so every top is going to get multiplied by 3. This is going to give me 3y minus 9 equals, these are going to cancel, negative 2x plus, these are going to cancel, 4. Okay. Now I need my letters together on one side and my constants on the other. So I'm going to add 2x to the other side. And I'm going to add 9 to this side. And that's standard form. Letters are on the left, no fractions. And we're done. Okay, so I know I kind of rearranged this in one fast step, but I just added 2x and then I added 9, and that's how I came up with that. Okay. All right, let's turn the page. Okay, we are going to skip number 4. This is not the synthetic division problem that I want to do. So we're not going to worry about 4. And we're going to skip 7 because that's not going to be a problem on the test this year. Okay, so we'll do 5 and 6. All right, 5 gives students trouble, and it shouldn't because it's meant to be pretty easy, but for some reason it just tends to really bother some students. So, okay, we're supposed to solve. We're going to get 2 answers because our biggest exponent's 2. When I look at this, I see we have a GCF of A. So I'm going to take an A, and I'm going to divide A out of both of these, and I get A plus 8. And now I'm just going to set each factor equal to 0. This is going to give me A equals 0, and this is going to give me A equals negative 8. And these are my 2 answers. I just set this equal to 0 and subtracted 8 to the other side. So simple, simple. Okay. Number 6 tells me to simplify, and I see fractions, and you know I don't want fractions, but I don't have an equal sign, so I can't get rid of the fractions. The best I can hope for is to combine the fractions. So I'm going to need an LCD. Well, I know it's going to have x in it because these both have x, but now I need the least common denominator for 14 and 3. Well, 3 can't go into 14. 14 times 2 is 28. 3 can't go into that. Excuse me. 14 times 3 is 42. 3 can go into 42. That's going to be my LCD. Okay, notice that really what I did was just multiply the number coefficients together. All right, so this is the denominator that I want. Okay, I cannot multiply the tops because I don't have an equal sign. So I want 42x, I have 14x. So I'm going to multiply top and bottom by 3 because that would give me what I want. It's going to give me a numerator of 9 and a denominator of 42x. Okay, I come over to this one. If I multiply top and bottom by 14, that's going to give me a denominator of 42 and a numerator of 14. Okay, so I can combine these with a denominator of 42x. If I add these numerators, I get 23. I can't reduce this, so I'm done. And that's the end. Okay. All right, let's go on and look at number 8. Number 8 comes from module 10, which is the only module we didn't get to. And that's okay because we're going to cover it in college algebra. But I want to make sure you understand this problem for the test because we do have an inequality with an x and a y, and it wants you to graph it. And when you graph an inequality, you shade in part of your graph. Okay, so we want to make sure you're comfortable. So first step is you want to solve for y. That's your first step. So I'm going to subtract 3x to the other side. Subtract 3x. Okay, there we go. Now we have this in slope-intercept form. So I can find out from here that my y-intercept is -7. I can also find out from here that my slope is -3/1. because I just put it into slope-intercept form. Now I know this is not an equal sign, this is an inequality, but it still gives you the same information. So this slope tells me, because it's -3, I'm going to go down 3, and because it's a 1 in the bottom, I'm going to go right 1. Now if this were +3/1, I would go up 3, right 1. Okay, so now I'm just going to graph this line. So I'm going to go down here, 1, 2, 3, 4, 5, 6, 7. There's my y-intercept, 0, -7. From this point, I'm going to go down 3, 1, 2, 3, and I'm going to go right 1. There it is. And then there's my line. Okay, now I have to decide which side do I shade. Which side am I going to shade? Okay, because I have to either shade this upper portion or this lower portion. Well, notice this cuts the y-axis into 2 parts. So you have all the y's greater than the line, and you have all the y's less than the line. This wants y less than. So you are going to shade everything over to the left so that you can have these y values that are smaller than the line. That is going to be your answer. Now, don't worry too much about this, because here's the deal. On the test, there will only be one correct line. So you don't even have to worry about the shading situation. You just have to graph the line correctly. There's only going to be one line that goes through and satisfies the slope and the y-intercept. And then you know that's got to be the picture. You'll have 4 pictures, you pick that picture. Okay? All right, let's look at number 9. Okay, so number 9, all right, has a complex fraction. These 2 denominators are not the same, so I can't just cross them out. I'm going to have to do keep, change, flip. So I'm going to keep the top. Okay, change to multiplication, and I'm going to flip the bottom. All right, now I'm going to seal off my packets. And then I look to see if anything can reduce, and I don't see anything that can reduce. So I am ready to just multiply the tops together. It's going to be x times this packet divided by the denominator, which is 5 times this packet. And there's my answer. And there's not anything else I can do. So simple enough. All right, number 10 is another equation with fractions. Okay, I never mind equations with fractions because I can multiply the tops and get rid of the fractions, right? So my LCD for this guy is just going to be x because that's my only denominator. But I do need to multiply every term, even that 2, by that LCD. So these cancel, these cancel. I'm going to be left with 3 equals 2x minus 1. Okay. Going to add 1 to each side, and I get 4 equals 2x. Okay, 4 equals 2x. I'm going to divide both sides by 2. And there's x equals 2. Easy enough. All right, number 11, simplify with positive exponents. Okay, so some students like to rewrite this guy so he looks a little bit more like fractions. Okay, so I just rewrote this as 5/1, and I rewrote this so he wasn't on the diagonal. But all we're going to do is multiply these fractions together. So 5 times 3 is 15. 1 times 5 is 5. 15 divided by 5 is b to the 3rd. And there we go. You're done. So yours will do the same thing. You just multiply, and you should be able to reduce perfectly. Some of you might even notice that you could actually cancel these out, and you just end up with 3 over 1. But you can always go through each step if you like it better. All right, number 12. Number 12, we are multiplying. Okay, so we're going to have our radical. We're going to multiply these coefficients. 3 times 3, we get a 9. Now, when we multiply exponents, we're actually adding them, right? So 2 plus 4 is x to the 6th. So we multiply the coefficients, we add the exponents. Now we can reduce this. The square root of 9 is actually 3. And then remember, this is an index of 2. So for the exponent, we're dividing. 6 divided by 2 is 3. And there we go. And that's what yours will look like. You shouldn't have anything left over. It shouldn't be anything strange. It'll be really nice just like that. Okay. All right. On to number 13. We have 13 and 14 on this page. Okay, 13, we have complex numbers. Notice they're also the conjugate, so we would expect all the i's to cancel. And we want to write our answer in a plus bi form. So we're going to actually have a strange answer for this one. So let's just go ahead and start. So we're going to FOIL. We're going to have 5 times 5, 5 times 2i, negative 2i times 5, and negative 2i times 2i. That's going to be minus 4i squared. Okay, now these middle terms are going to cancel. We're going to get 25 over here. Remember, I squared is negative 1. So this is negative 4 times negative 1. Remember, my little trick is when I see I squared, I kind of just forget about it and I change the sign of the term with it. So plus 4, this is going to end up being 29. Now on any one of my tests, that would be perfect, but on the final exam, that is not even going to be a choice. So it wants A plus BI form. Well, this is the A portion, okay? What would my B portion be? Well, I don't even have an I, so you would put 0I. That is the form that they're going to want on the final. That's what you're going to see, okay? You will not have this as an option, okay? All right, number 14. This is Pythagorean Theorem. So you're setting up a volleyball net, and one of the poles forms a right angle with the ground, okay? It is 7 feet high. A rope is attached to the top of the pole and a stake that is 12 feet from the bottom, okay? So, you know, your net is over here, and then you have this rope that you stake down in the ground, okay? So we're trying to figure out over here, what is this? I guess I should call it C. The length of this rope, okay? So remember your Pythagorean theorem, a squared plus b squared equals c squared. These are your A and your B. So it doesn't matter which one you name which, just know that you're going to take both of the numbers from the problem and you're going to square them. So you really don't even need to draw a picture. You just pop your numbers out and square them. Okay, 7 squared is 49. 12 squared is 144. Add those together and we get 193. Now I will caution you, 193 will be an answer choice, but you cannot pick it, correct? Because you want c squared. So don't get too anxious. And this says to find it to the nearest tenth. That means 1 decimal place. So when you take the root of 193, round it to 1 decimal place, and you get 13.9. And that's the one that you want, okay? Okay, moving along. Okay, we have 15 and 16. 15 we are not going to worry about because your domain and range is going to be the parabola problem, the typed one that we did at the beginning. Okay, now this one wants you to graph. Now, of course, on the final, you'll just have to pick the graph that matches. this particular equation. Well, notice he's already in slope-intercept form. So he's ready to go. I have a y-intercept of -4, and I have a slope of 1/3. Now my slope's positive, so that means I'm going to go up 1 and I'm going to go right 3. And that tells me what my slope looks like. All right, y-intercept. So I'm going to go down 4. Here's my y-intercept. Okay. And my slope says I'm going to go up 1, right 3. So this would be my next point. And there is my line. And that's the one you're going to choose. Okay. All right, so I think the rest of these, we got to do every single one of them. But we're very, very close. Okay, actually, just kidding. I don't even think we have 26. We did 26 before? Huh, we did, and we didn't even have to. Okay, here we go. Just thinking about my last class. All right, so 17 and 19. These are both the only word problems that you have on the test. Okay, 17 and 19, but they are a little tough. So we have to make sure you know how to set these up. Number 17, you have to write a system of 2 equations, and then you have to solve them. Okay, so you're going to have to write 2 equations. Your first equation is just going to deal with how many people are at the play. Your second equation is going to deal with money. Okay, so that's what we're going to do. We're going to have one equation, that's how many people, and we're going to have one equation, that's money. Okay, now we're going to need X and Y. So let's make adults X and let's make children Y. All right, so this says there were 640 people at the play. So that's adults and children. The admission price was $3 for adults and $1 for children. The admission receipts were $860. How many children and adults attended? Okay, so you're going to write 2 equations and then you're going to solve them. So our first equation is just going to be the number of people. So we know there were 640 people at the play. So that means some number of adults and some number of children added together to give us 640. Okay, that's how many people were at the play. Our second equation is going to deal with money. So this says $3 for every adult, $1 for the kids, so 1Y or just Y, and all this money totaled up to give us $860. This is your system of equations. So you're going to rely on this same setup, okay? First equation is just X plus Y equals the total people. Second equation is 3X and 1Y, whatever these prices are, and they're going to add together to give you the total money made at the play. Okay, so this is our system. We need to somehow solve this. So you have 2 choices. I notice our Y's are very similar except they have the same sign. So we could multiply one of these equations by a -1 and cancel out the Y's. Or if you don't like elimination, you could solve this top equation for one of these variables and substitute it in for the other one. So it's really your decision. I'm going to multiply the top one by a -1, okay? Now I had to multiply everybody. That's what students seem to be forgetting. So this is going to give me a -1x minus y equals -640. Now this bottom equation stayed the same. We didn't do anything to it at all. And then we're going to add these guys together. So I'm using elimination. I just multiplied that top one by a -1. When I do that, my y's go away. So -x plus 3x is 2x. Negative 640 plus 860 is 220. Divide each side by 2, and x equals 110. Okay, now remember we said x were adults. Okay, so we have 110 adults that went to the play. So how are we going to figure out how many kids went to the play? Well, we know 640 people were there total. So if I do 640 minus 110, I get 530. That's how many kids were at the play. So these are my answers. Okay, so that's got a lot going on in that problem. Make sure you practice it. Practice the setup, practice solving it, and then make sure you can get both answers. Okay. All right, let's look at 18. 18 wants you to solve a square root problem. Okay, so this is where we use that IRSC thing, right? So the I for IRSC means isolate. So I'm going to add 3 to both sides. And now I'm isolated. Now this is a square root, so I'm going to square it. This is going to pop off your radical, and you get a 9. Now I'm just going to solve. I'm going to get 2x equals 4. Divide both sides by 2. And my answer is x equals 2. I don't know about you, but I feel like x is 2 for everything on the study guide. Okay, there we go. So isolate, then square it. All right, this is your last word problem. You only have these 2. Okay, we want to make sure you know how to do this. So this one's going to talk about a TV. Yours on your final is going to talk about a ring. Okay, so just in case you want to, this will be the play with the kids. This is going to be a ring, just so you can identify them separately. Okay, so this says that this item sold for this much money, including tax. So that's what they had to pay. If the tax rate is 7.5%, find the price of the TV before the tax was added. Okay, so here's what we know. We paid some amount for the TV or the ring. Then, so this was our purchase price. This was the price of the item. Added to that is the tax. And then that equaled this amount over here. Okay, I think we can all agree with that. Price plus the tax, there's your amount. Okay, so how do we put into the equation the tax? Well, I'm not sure if you're familiar with tax, but what happens is they take the tax rate and they turn it into a decimal. So we would take the percent, divide it by 100, we would get 0.075. Okay, so we turned it into a decimal. Then to find the amount of tax, they multiply this by the price. So the amount of tax is that decimal multiplied by the price. So this is how you would find your total. I mean your price before. So price of the TV or the ring plus tax as a decimal times the price equals the total. Okay. This is the hardest part, remembering this. Now these are like terms, so we're just going to add these together. We have 1x plus 0.075x gives us 1.075x, and that's what gives us this. So I just added those two items together. Okay. Now I'm going to divide both sides by the 1.075, and I end up with $2,500. That was the price of the TV before tax. Okay, so this would be what you're dealing with. I think on the final your ring is going to be 6.6%. So your equation is going to be x plus, because it's 6.6%, 0.066x equals whatever this amount is they give you. And then you would add these together and then divide both sides by the 1.066. Okay. All right, turning it over. We're getting really close. I know this is long. All right, number 20. Okay, number 20 is that other radical one I told you about that I wanted to do with you that was a little more similar. Now, let's get rid of the plus and let's make it a minus, just to make it a little more true to your final, okay? All right, so here we go. I can't subtract these because I don't have the same radicand. So I'm gonna take 48 and I'm gonna break it down. You can break it down any way you want to, but remember, you're gonna end up with 4 2s and 1 3. Now we want groups of 2, so we're gonna take this group of 2 and this group of 2. Okay, so this gives us a 2, this gives us a 2, and we have a leftover of 3. So 2 times 2 is 4, root of 3. Okay, so that's what this one turned into. It didn't have any kind of coefficient out front, so I didn't have to multiply. All right, let's try 147 now. 147 is strange. It's not anything that I'm familiar with. So I put 147 in my calculator. I divided it by 2. I got a decimal, so that didn't work. Then I divided it by 3, and I got 49. So that worked out really nicely because I also know that 3 and 49 is going to give me 377. Okay, here's a group of 2. If I pull out a 7, I'm left with a 3. Remember, leftovers go inside. Okay, I don't have a coefficient, so there we go. That's this one. Now I can subtract these because I have the same radicand. So 4 root of 3 minus 7 root of 3 is a negative 3 root of 3. And there's my answer. Okay. All right, number 21, we're going to multiply. So remember, the point of multiplying these is that we're trying to reduce. So let's look at our first numerator, and I see a GCF of 54. Now, if I divide both terms by 54, I'm going to be left with x plus 1. Do not forget that 1. They're trying to catch you and see if you forget that if you start off with 2 terms, you better end with 2 terms, right? Okay, this denominator, I can't do anything with 4x minus 9, so he just gets a parenthesis. All right, I come over here, I'm looking at this. I'm seeing another GCF of 7. So I'm going to divide top and bottom by 7. It's going to give me, not top and bottom, I'm sorry, each term, 4x minus 9. Look at that. That's nice. We can cancel those. Okay, this guy here, I also see a GCF. It's 6. So if I divide each one of these by 6, I'm going to get x squared minus 1. But I'm not done. This is a difference of squares, right? So I'm going to have a 6, but then I'm going to have 2 packets, plus and minus, square root of the first, square root of the second. Now I'm completely factored. So x plus 1 and x plus 1 cancel. 4x minus 9, 4x minus 9 cancel. Okay, my numerator is going to be 54 times 7. That's 378. Over 6 times x minus 1. Okay, now before you circle it and think you're finished, it's always a good idea to check this, right? 378 divided by 6 is actually 63 over x minus 1. That goes in there perfectly. And that's because these guys could have reduced. We could have pulled a 6 out of that and gotten a 9. And then 9 times 3 is 63. So that's what happened there. Okay, here we go, 22. Okay, just a good old simplify here. All right, so I notice I have a monic in the top and a monic in the bottom. Okay, no GCFs. This top one is going to factor nicely just like this. So you could always do A is 1, B is 6, C is 8 if you like that ABC. We want to find two factors that multiply to give us 8, and they need to add to give us 6. So that's going to be 2 and 4. Okay. All right, down here in the bottom, same thing, it's a monic. Now, if you happen to notice, it's also a PST. Square root is x, square root is 4, 2 times 4x is 8x. So these are going to be exactly the same. They're going to be x plus 4. Okay. If you didn't catch that, that's okay. You can still do A, B, C. We want factors that multiply to give us 16, that's A and C. We want them to add to give us 8, because that's B. And that's where we get the 4 and 4. Okay, and they're exactly the same. All right, so these cancel. And your answer is going to be x plus 2 over x plus 4. There we go. Okay, number 23, we're going to have synthetic division. So remember, these are your coefficients that go straight in the line. You will not be missing a term. Yours will be in order. So 1, 4, 7. Now we have a shelf. Remember, if your denominator is x plus 2, what's going on the shelf? Negative 2. That's because we're solving for x. So that's where that negative 2 comes from. Okay, we're solving for x. All right, bring down your first term. That's how you get started. Negative 2 times 1, negative 2. Add, we get a positive 2. Negative 2 times 2, negative 4, add, we get a 3. This is your remainder. You will have a remainder, so be prepared. We started with x squared, so our answer is just going to be x plus 2, and then here's our remainder. So we add the remainder, and the denominator becomes the denominator of the remainder. That's our answer. Okay? All right. We're getting there. 3 more. Okay, 24. 24 and 25, these are your quadratic formula problems. They are both going to be quadratic formula, and they're both going to say solve. Now, don't worry about your quadratic formula because you're going to be given this. Here it is, but if you don't remember it, don't panic because you're going to be given this, so you don't have to know it. All right, so here we go. We are going to use quadratic formula. How do you know you have to use quadratic formula? Well, you need to look at your answer choices. And for both of these problems, your answer choices are going to be crazy looking. They're going to have i's in them. They're going to have radicals in them. So it should be obvious that you can't factor them, that you are going to have to use quadratic formula. Okay, so here we go. A is 1, B is 6, C is 25, and we're just going to plug it right in that formula. So we're going to have opposite of B, negative 6, plus or minus 6 squared, minus 4 times 1 times 25, all over 2 times 1. Okay, make sure you can see that. All right, let's clean it up a little bit. Okay, so this is going to be negative 6 plus or minus 6 squared is 36. 4 times 1 times 25, we're going to subtract 100 all over 2. Okay, we're going to keep going. Negative 6 plus or minus 36 minus 100 is negative 64 all over 2. Okay, here we go. Now, Anytime you see a negative inside a square root, I hope you automatically think of I and pull him out. Then the square root of 64 is 8. Okay, so hopefully you all got that step. Now, I see the triangle where every point can be divided by a 2. If I divide every point by a 2, I get -3 plus or minus 4i because it's all over 1. And there's my answer. Okay. All right, let's try this one. Okay, so again, your answer choices are going to have weird stuff happening, so it should be obvious you're not factoring. Okay, I cannot tell that B is -12, and I cannot say that C is -3. I have to move all these terms to one side before I label A, B, and C. Do not start pulling them out from that point. Okay, so A is 6, B is 12, and C is 3. And I'm going to plug it right in my formula. So opposite of B would be -12 plus or minus square root of 12 squared minus 4 times 6 times 3 all over 2 times 6. Okay, I'm just plugging everybody in. All right. -12 plus or minus, all right, 12 squared is 144. 4 times 6 times 3 is 72, all over 12. Okay. All right, let's clean up that radicand. 144 minus 72 is, believe it or not, 72, all over 12. All right, well, I have to clean up this radical. 72 is not a perfect square root, so I'm going to have to factor tree him. I think of 8 and 9, so I'm going to start breaking him down. Okay, and I break him down to 3 2s and 2 3s. Okay, so if I want to circle groups of 2, here's a group of 2, here's a group of 2. Okay, so just writing everything over so I can handle that root of 72. If I pull a 2 out and a 3 out, that gives me 6, and I've got 1 2 left over. So 6 root of 2. I just pulled out one of each, multiplied them together, and then I had a 2 left over. All right, now I do still have a triangle, but I'm not dividing always by this denominator. I'm dividing by whatever point of the triangle is able to be divided into all 3 numbers. So all 3 of these can be divided by 6. Okay, that's going to give me -2, I'm dividing him by 6, root of 2 divided by 12 divided by 6 is 2, and that's my answer. It's gonna take a lot of willpower for you to not reduce any further. There's nothing else you can do. You cannot go inside that radical, and you can no longer make a triangle. So you are completely done, and this is your answer, because we divided all points of that triangle by 6, okay? So you may want to practice that one. That's a pretty difficult quadratic formula problem. Okay, then the very back, here we go. 26 is not a problem for the test, so you do not have to worry about that. But we do need to worry about 27. So we have a system of equations. It wants you to find the x value only. So you do not have to find the y also. You just have to find the x. Now, the way yours are going to be set up, your y values are going to be exactly the same. Now, you could use substitution if you want to, but it's going to be a lot more work. If I were you, because this wants an x value, I would eliminate y. That's what I would do. So all I have to do to eliminate y is to make one of these guys negative. So if I multiply everybody in that first top row by -1, I'm going to come up with negative 4x minus 3y equals negative 4. Then I'm leaving everyone the same in the bottom row. I'm going to add these together and y gets eliminated, which is fine because I only want x anyway. Negative 4x plus 2x is negative 2x. These add to give 8. I divide by a negative 2, and x is negative 4. Now be careful because this is correct, but it is not going to be an answer choice. So your answer choice, normally it looks like this. Normally you put your x value here and then you put your y value here, and it's like a little coordinate pair. But we don't know why, so what they're going to do is put this weird funky little asterisk in there, and that's the answer choice that you're going to go for. Okay, so that takes care of your study guide. Go back over this over and over again. These problems are what you're going to see, and if you are comfortable with these and can do these problems, then that's an A. You've got it. So I will see you on final exam day next week, Monday or Tuesday. Bye-bye.